Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, hello everyone. Today I'm gonna discuss another questions. This is an interesting questions regarding polynomials. Now, for this particular video, I have written my solutions. So I've written my solutions on the blackboard, and I'll be explaining step by steps how to do the questions. Okay, so I think this method would be much better than rather than I'm doing it from scratch because it gives me some guides the to where the explanations has to be. So I think it would be more efficient if I do it this way. Okay, I think let's start by reading the questions first. Okay, now we know that we have a polynomial gx equal to ax squared minus bx plus a minus b. Okay, and then the factors, we know that the factors of this polynomial is x minus 1. This is a linear factors. Okay, this is the first informations. Okay, focus on this one. Gx is equal to ax squared minus bx plus a minus b. So I put a bracket here to show that this is the constants of the polynomials. And since x minus 1 is the factors of gx, uh, and this is of gx, it means that the remainder when it was divided by x minus 1, it would be 0, right? Or in other word, the value of g minus 1 is equal to 0, right? This is g minus 1 according to 0, according to reminder theorem, right? Okay. Uh, okay. And then the second information that we got from the question is that we have a polynomial fx. We don't know the degree of the polynomials, but we knew that if the fx is divided by x minus 1, it will have a residue of a. Yeah, this is the first information. Fx when divided by x minus 1, the remainder is a. And then when divided by gx, so when divided by gx, the fx, it will have a remainder of 3ax plus b squared plus 1. Okay. And the questions ask for the value of a. Okay. So, uh, okay, what's the first step that we have to make in order to solve these questions? Okay, let us start by digging from the scratch, from the first informations of gx. Okay, we know that polynomials, of course, we know that by basic informations of polynomials, regarding polynomials, we know that the polynomials can be stated according to its divisors and its quotients and its remainder as fx. So fx is a polynomial that we want to describe, is equal to px. Px is the divisor, hx is the quotients or the result of the divisions, and sx is the remainder. Sx is the remainder. S of x is the remainder. Now we know that gx, I want to describe the gx. Okay, so gx would be equal to the divisor. I'll use the x minus 1 since that's the information from the questions. So x minus 1 times hx. So we don't have to know exactly what is the result of the quotients. So let's just wrote it as hx plus a plus a as of x. Yeah, as of x. And then from here we could pick for every value of x. So, but I'll pick x equal to 1. I'll pick x equal to 1. So I'll pick x equal to 1, yeah, because since x equal to 1 is the factors of these polynomials. Okay, so I'll pick this one. Why did I choose the x equal to 1? It's because if I choose x minus 1, the quotients would be disappeared and it will left us the s of x, okay? And it would be uh, quite an informative informations that we would use in the futures. So we know that if we insert x equal to 1 to the equations, we know that replace all x with 1, so g1 is equal to s1, and because x minus 1 is a reminder is the factors of gx, then the remainder would be equal to 0. And we know that g1, we could insert it into the equations ax squared minus bx plus a minus b, replace the x with 1, and it would result that the gx become a minus b plus a minus b, which eventually get us to these conclusions that a equal to b. Okay, so we know that the value of a would be equal to value of b. Yeah, a equal to b. And then the second information is regarding the fx. Okay, so we have already done with the gx. Now we're going to digging the information from the fx. So we know that fx is a polynomials, and we have two informations. Yeah. So when divided by x minus 1, the remainder is a. When divided by gx, the remainder would be 3ax plus b squared plus 1. Okay. Let's just let us start it from the x minus 1. So again, we could use the fx equal to pxhx plus sx as of x, and I'll replace the divisor with x minus 1. So fx equal to x minus 1 hx plus s as of x. Now, of course, we could choose random value of x, okay, but I'll use the x minus 1s. X equal to 1, I'll pick the x minus 1 because since x equal to 1, if I choose the value of x equal to 1 to this equation, the quotients would be equal to 0. So this part would be equal to 0, so we don't have to find the value of hx. So x equal to 1, therefore x f of 1 equal to a, yeah, because reminder is a, so s of x would be equal to a when the x equal to 1, right? And then the next one, okay, the next one is that fx when divided by gx, the remainder will be 3ax plus b squared plus 1. So again, we could describe the fx using these relations, bx times hx plus s of x. And of course, I would replace the divisor with gx since the divisor is gx. So gx times sx plus 3ax plus b squared plus 1. And the next thing that I will do is that since gx has a vector, so we know gx is this functions, and this functions has a factor of x minus 1. It means that if we choose x equal to 1, this polynomial would equal to 0, right? So we choose x equal to 1. So again, I choose it because gx has a factor of x minus 1. And if we since if we choose the x minus 1 to this equation, the gx would be equal to 0. Yeah, according to the reminder, according to the fact theorem factors theorem. Okay. So if I choose x equal to 1, the gx would be equal to 0. It means that this term would be equal to 0. So we don't have to consider what is the quotients is. And then we would left with 3ax plus b squared plus 1. We replace the x equal to 1 since we choose x equal to 1. That means that f1 is equal to 3a, yeah, plus b squared plus 1. So f1 is equal to 3a plus a squared plus 1. Now we knew that from the previous informations that f of 1 is equal to a, yeah, when it divided by x minus 1. And we also knew that if we divided if we divide the polynomials with gx and we choose x equal to 1, the f of 1 will equal to 3a plus a squared plus 1. So this equation shows the exact values, the same values. So we could build an equation from here. Yeah. So 3a plus a squared plus 1 would be equal to a. Yeah. Since this was a same value, has the same value. And we could do some simple factorizations. It would become a squared plus 2a plus 1 equal to 0. And this would be a plus 1 squared equal to 0. That means the value of a for these equations to be true is that a equal to minus 1. Then we find the value of a would be it would be minus 1. I think that's all for the solutions of these questions. This is a tough questions to do, especially in particularly if you're doing it on an exams. Yeah, so you're in a rush of times. Yeah, you have a time limit, so you have to consider that into your solutions. But of course, if you're doing it outside the exams, you could do it freely without restrictions of time. But this is a quite challenging questions that appear in my exam. So yeah, at first, I cannot do it. I cannot do the questions, but I find it to be easy actually. Yeah, if you're doing it outside the exams, even though I have to review some of the properties of polynomials. Yeah, because to be honest, I'm not really familiar with the law and the properties in the polynomials. In fact, it's a fun fact actually is that I'm not really intrigued at first with polynomials, but after I found out that, oh yeah, it's kind of interesting. So yeah, I decide to learn more about it. Yeah. And this is why I learned polynomials so much. Yeah, because you can use you can use a theorem to describe something that seems peculiar, but in the end you get a nice end result, and it sparks a little bit of enjoy, when you solve the questions. Okay, I think that's all for today. Yeah, thank you for listening to my video. I'm sorry if I do my solutions, uh I kind of lack of on explaining the solutions to all of you. I'm so sorry for my English pronunciations, or maybe my lackness on explaining the solutions to all of you. I'm sorry. Yeah, if you have any suggestions, or you might have complaint maybe, or maybe questions regarding the solutions, you can leave it on the comment sections. Okay, I think that's all for today. Thank you for listening. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.